So today the topic is limiting reactants, right? Let me clear your concept about what is a limiting reactant. Then we will be heading towards the numerical problems. So what is actually limiting reactant? We can define this as a reactant that completely consumes in a chemical reaction, or the reactant that produces least amount of product, either in mass or in moles, or the reactant whose consumption result in the stoppage of reaction, or after the consumption of limiting reactant the reaction will stop. Let me give you a simple example, the diagrammatic example that we have just studied in our previous class with boys. No, Noor
Sir,
Fatma
वो
is not,
ईमान
I think.
फातिमा
All right. Is this Iman Fatma?
जी सर
So for example, we have, let's assume, 5 triangles, right? And also we have, let's take an example, we have 8 circles. For a reaction to complete, let's assume for one rectangle we need one circle to form a reaction, or to complete a reaction between circle and triangle, right? So whenever we are going to mix triangles with circles, we will end up with getting some products like one triangle and one circle. All right. Again, one triangle and they will react together. In other words, 5 triangles will attack on 5 circles to form 5 products. And these circles will remain at the end of the chemical reaction, right? Because 5 circles have been consumed with 5 triangles, right? But 3 of circles have been left at the end of chemical reaction. Now look at the definition number 1. Which reactant among these two that is completely consumed in a chemical reaction? Which one is that reactant, Shabash?
triangles
Excellent. And also, which one is the reactant that produces the least amount of product? Triangle is producing 5 products, right? And also circles are 8, so if the circle wishes, it could have made 8 products, but as the triangles are limited, so that's why the extra circles will remain unreacted at the end of chemical reaction. So we can say that the triangle reactant is limiting reactant. All right. Whereas this one is non-limiting or excess reagent. Is it clear? Is it clear, dear students?
yes sir जी सर
Okay. Yes. So we are going to study another example. For example, in case of water molecule, just quickly, we have one hydrogen molecule, 2 hydrogen molecules, and 3 hydrogen molecules, right? And we have, for example, just one oxygen molecule. So what will happen? One oxygen will make bond with 2 hydrogen atoms. Another oxygen will also make bond with 2 hydrogen atoms, and one hydrogen will remain unreacted at the end of chemical reaction. So which one is limiting, Shabash? Which one is limiting reactant?
ऑक्सीजन
Oxygen. Excellent. Understood? So oxygen is limiting, and this one is excess or non-limiting. Point number 1. Now remember, this amount of product is directly proportional to the amount of limiting reactant at the beginning of reaction. More amount of limiting reactant, more will be the amount of product formed. Understood? Clear? Now we are going to solve this numerical problem. You should carefully look towards this problem. We have been asked to find the limiting reactant between the reaction of sodium and reaction of sulfur, right? So first of all, we are going to write reaction. Sodium, right, reacts with sulfur to form sodium sulfide. We have been given mass in gram of sodium is 9.2 grams, and that of sulfur is 8.0 grams. Now, for simplification, I'm making two columns right over here just for the sake of simplification, for the sake of clearing your concept in pretty much detail, right? We will be first comparing sodium with sodium sulfide and then sulfur with sodium sulfide. Now, like that, first of all, sodium is the mass of sodium is given in gram, and we know that in order to calculate number of moles of product through molar ratio method, we need to find number of moles of sodium, right? So first of all, we are going to calculate number of moles of sodium, that will be equal to mass in gram divided by molar mass. Just calculate it within no time. Hurry up, anybody, calculate it down. So again, we are going to compare sodium with sodium sulfide. Remember the last step? Remember the last lecture? The first step will be from the balanced chemical equation. As we know that, according to balanced chemical equation, 2 moles of sodium reacts with sulfur to form 1 mole of sodium sulfide. Clear? Now, the next step should be for given data. So zero point 0.4 moles of sodium is going to make x moles of sodium sulfide, right? So 2 into x is equals to zero point 0.4, or x is equal to zero point 0.4 by 2, which will be equal to zero point 0.2, right? Moles of sodium sulfide. Clear? And then we are going to convert this number of moles of sodium sulfide into mass in gram by using the formula moles into molar mass. So moles of sodium sulfide is zero point 0.2, and the molar mass of sodium sulfide is 23 multiplied by 2, plus the answer will be, is Anadim, please turn off your mic, please. Is Anadim, please.
78.
78 grams per mole. We are going to multiply it with 78 grams per mole. This is mole, this is gram per mole, so mole will cancel out, and the answer will be,
15.6.
15.6. Are you sure about that? 15.6 grams. Please
Let
do the
me check
calculation
it.
correctly. Do this one again. Is it
0.2
point
वाला.
4? No,
15.6.
this one. This one. Do this one again.
0.4 आ रहा है इसका.
All right. And also multiply zero point 0.2 with 78.
15.6.
All right. Now, again, we are going to compare sulfur with sodium sulfide. First of all, we are going to convert the mass of sulfur in mass of sulfur to moles. Sulfur is 32. So tell me the answer, please. 0.25, I guess.
जी सर.
All right. And also, now we are going to compare moles of sulfur, which is given data over here, with the moles of sodium sulfide. So first step will be again from the balanced chemical equation. We know that 1 mole of sulfur reacts with sodium to form 1 mole of sodium sulfide. So of course, 0.25 will make 0.25 moles of sodium sulfide, right? Again, we are going to convert this into mass in gram, right? By using the formula number of moles into molar mass. So number of moles are 0.25 and molar mass is 78 gram per mole. So mole will cancel out. Now calculate this one. Multiply 78 with 0.25.
19.5.
19.5 grams. Now look at here. This is the main point. Sodium is going to make 15.6 grams of sodium sulfide, right? Whereas sulfur is going to produce 19.5 grams of product. Which one is the least?
Sodium. Sodium.
Yes, sodium is the least, so it means we will be giving the award of limiting reactant to sodium because it is producing least amount of product, right? So sodium is limiting reactant, whereas sulfur is non-limiting reactant or excess reactant. Is it clear now? Because we have just learned the definition that the reactant that produces least amount of product. the reactant that produces least amount of product. So sodium is producing 15.6, whereas sulfur is producing 19.5. So of course this one will be limiting reactant. Is it clear now, dear students? Is it
Yes,
clear?
sir. Yes, sir.
Now we are going towards this question quickly. Again, we will be dividing into two columns. First of all, we will be comparing which one? Hydrogen gas with water, and over here oxygen gas with water, right? First of all, we are going to convert this mass of hydrogen gas into number of moles. So mass of hydrogen gas is 8.0 gram and molar mass of hydrogen gas is shabash 2. So the answer is 4 moles. Is it clear? Now again we are going to compare by molar ratio method, and that is hydrogen ratio water. So according to the reaction, 2 moles of hydrogen, according to the balanced chemical equation, 2 moles of hydrogen reacts with oxygen to form 2 moles of water molecules. Clear? So 4 moles, right, will form X. So X multiplied by 2 is equals to 8, or X is equal to 4 moles. Is it clear? Now we
Yes,
are
sir.
going to convert this number of moles into again mass in gram. This is the basically moles of water, right? So we are going to convert this mole into, oh, sorry, mass in gram into moles. So 4 moles multiplied by the molar mass of water, much better, is 18, right? So mole will cancel out each other and the answer will be
72.
72 grams. All right, now again we are going to compare oxygen with water. First we have compared water, hydrogen with water, and then we are going to compare oxygen with water, right? So number of moles is equal to 64.0 grams of oxygen divided by molar mass of oxygen is much better, is 32 grams per mole, right? So we are going to write 32 grams per mole. So the answer will be 2 moles. All right, again comparing oxygen with water, according to the balanced chemical equation, we know that 1 mole of oxygen will react with hydrogen to form 2 moles of water. So the given data is 2 moles of oxygen will react with hydrogen to form X moles of water. So again we are comparing X is equals to 2 multiplied by 2, which is equal to 4 moles of water, right? So again we are going to convert this mole of water into mass by using the formula MR. The number of moles are 4 and molar mass is 18 gram per mole. So what should be the answer?
72.
Yes. What do you think now?
Equal है दोनों.
So which one is limiting reactant
Both.
and which one is in non-limiting or excess?
None.
So remember that 1 mole of oxygen react with 2 moles of hydrogen to form 2 moles of water, right? So the question, the tricky question, examiner has given us exactly the same number of moles and same number of molecules, right? The examiner has given double number of moles of hydrogen and half number of moles of oxygen. In other words, 4 moles of hydrogen and 2 moles of oxygen, right? So that's why you cannot identify that which one is limiting reaction, because this is the scenario like this one. For example, we have 3 triangles and 3 circles, so of course both will react together to form exactly the same products, right? Clear? I hope you are going to do other questions as well. This you should practice these questions. I will be sending this question now. Over here, for example, in this scenario, is anybody waiting in the lobby? Let me check. No, no one. No, so all right, now looking towards this question, is the previous question cleared, every students?
Yes,
I
sir.
need the response from every student.
Yes, sir.
Right. So again, we are going to compare first of all sodium with sodium sulfide and then sulfur with sodium sulfide, right? So again, we are going to convert number of moles of sodium into, sorry, number of atoms of sodium into number of moles. 10.24 divided by Avogadro's number, and that is equal to, just do it please. Do it, students. Are you doing it?
1.993.
1.99 moles, right? So again, we are going to compare sodium with sodium sulfide. According to balanced chemical equation, 2 moles of sodium over here will react with sulfur to form 1 mole of sodium sulfide. So the given data is 1.99 will react to form this one. So 2x is equal to 1.99, or x is equal to 1.99 divided by 2, and that will be equal to 0.98, I guess. Just do it.
0.95. एक मिनट एक मिनट
Yes.
0.995.
Okay, 0.99. All right, moles of sodium sulfide. Again, we are going to convert this mole into mass, right? Mass is equals to moles into molar mass. So moles are 0.99 and molar mass is molar mass of sodium sulfide we have just calculated. 23 multiplied by 2 plus 32, and that equals 46 plus 32, 78. So moles into 78 grams per mole.
77.
Yes, so the answer is
77.61.
77.6 grams, right? Now again, we are going to convert number of atoms of sulfur to number of moles by dividing number of atoms by Avogadro's number. We have practiced these type of questions a lot, remember? So again, sulfur ratio sodium sulfide. As we know that according to the balanced chemical equation, 1 mole of sulfur react with sodium to form 1 mole of sodium sulfide. So 1 mole, of course, X will be 1 mole of sodium sulfide, right? Now we are going to convert this again into mass in gram, moles into molar mass. So 1 into 78 grams per mole, right? So the answer will be 78 grams. Now look at here again, 77 grams and 78 grams. So which one is the limiting reactant, please?
Sodium.
Again, sodium, right? So sodium is limiting reactant. Is it clear, dear students?
Yes, sir.
Yes, sir.
100%. All right. So over here, sodium is the limiting reactant. Now concentration.
सर लेकिन
Yes, please.
रोल नंबर तो हम एमआर
What?
से कर रहे
Because in the question we have been given with number of atoms. When the number of atoms are given, you will have to first convert into number of moles. When mass in gram is given, then you will have to convert this into moles by dividing by its molar mass. Is it clear? It depends upon the given data. Clear?
Okay, sir.
Yes. You are going to solve these questions as well, right? Produce ammonia.